Okay, good morning all. So previously we have seen that how the different solvers are working and what are the different way of solving the calculating the response of a system, mostly HDOF, because we have only studied HDOF till to date. So we have applied the loads on that different type of function we have applied. We have seen some of the cases we can able to calculate the response directly using the D operator method. We have seen the full series of the D operator method. Then there is also some numerical recipes are there. For example, we can use the explicit method and implicit method. In explicit method, we have studied the central difference and Euler's integration scheme, and also in the implicit method we have studied our constant acceleration or the average acceleration, then linear acceleration, then numeric beta, and then we have studied the state space approximation, how to do that. That is mostly used for the multi-degree freedom. Then we go for the Runge-Kutta solvers. After that, they started discussing the Fourier series, because any function can also be represented as the Fourier series. So we started the Fourier series. Okay. So in the Fourier series, so maybe I will just quickly give a recap of the Fourier series and we will then continue from there. So if we see, we have a function, means that is our basic equation of motion, that mx double dot plus cx dot plus kx equal to force. Now we may have the f of ft, something is there. Now we can able to express the f of ft as the, so that is some of my f of ft function, some forcing function, some random function. We really don't know how it is made, but we can do what? We can able to express this function as the summation of several harmonic functions. That we can able to do, and we can able to calculate what are each of the harmonic functions, what is the amplitude of that, and what is the phase of that. And now if you sum all those, we will able to recapture our original signal. So that technique is known as the Fourier transformation. So here basically what we are doing, we have several data point and we are going to some sort of coordinate system which is made of sine, cosine and some constant value. So that is nothing but a projecting on some coordinate system. Obviously it's a n-dimensional space, not a 1 or 2 dimensional space, because you can see it is like a cos omega nt, sin omega nt, so it's like a going quite a huge number actually. Okay, so here if we see, actually in the last case we have made a small mistake, that is n should not be here, n should be here. Okay, that is n into omega t. Okay, that is, so n is somewhat 1 2 3 4 5 6, so it's a set of integer numbers. Okay, so we are basically doing what, like cos of omega t, means suppose a1 cos of omega t, b1 sin omega t, a2 cos 2 omega t plus b2 sin 2 omega t, like this way. We are having that full series with a term a0 by 2. Okay, so what we are doing, we try to represent that known forcing function with this series. Okay, how we can able to do that? So this is basically a optimization problem. We are try to approximate the function with this. Suppose in the, so nowadays a lot of people are using the machine learning, AI, for doing some sort of graph fitting. Okay, so what there you are doing, so you are trying to fit some equation. How to fit that equation? You are assuming that say data set minus this function gives some sort of residue, and you have to integrate over the domain so that the residue will be minimized. Okay, and how you are calculating the error? Error is nothing but r square. So whatever, like suppose, so these two are the two coordinates, like for example if I see this value is yt and this expression is here. So this is my error, and I am just calling that error as a R. Okay, now this can be plus or minus, so I'm just taking the square root of it, so it will be like absolute value. You can take ABS, or you can also take the square root. Square root is more convenient because it gives some of the thing, but never do the square root here. If you do the square root expansion, you are gone. You cannot able to solve it because it is already so complicated thing. If you expand it, first of all, it is almost not possible to expand, because you know that a plus b whole square, if you do, it become a square plus 2ab plus b square. Now if you do a plus b plus c, if you do that, it will become a sixth term. Fourth term if is there, it will become, so it's increasing actually. So it is not at all feasible to do the squaring there directly. And also what we have to do, we don't know what are the coefficients of this thing, so these are unknown values. So to identify that unknown value, what we have to do, we have to do a partial differentiation of that, so that we can say that partial derivative of with that is reducing. Okay, because if we plot the graph, so del y del x should be equal to 0. So once we are calculating the error, we try to minimizing the error with respect to that particular coefficient. How we get a minimization function? So once dy dx equal to 0, and then we check that d2 by dx2 is positive or negative. Am I right? So here also the similar thing is applicable, that we are having the r square, so that is my error. Integrate over that full domain is the complete error over the full domain. Then we are doing the derivative with respect to partial derivative. Please remember, not derivative. If it is derivative, we cannot able to solve again. It is partial derivative. Partial derivative with respect to that particular axis, so that we can able to calculate that what should be the value of that, or what should be the expression of it. So therefore this term is actually coming into picture. So whatever the unknowns are here, so this is the unknowns. Okay, so unknowns we are substituting here, and we try to calculate the full thing. Okay, so now let's do it. So now we will rewrite the full thing again, and we will start doing it. Yes, any question by that up to this? No question. Very good. So we can see that maybe our function is y of t should be equal to a0 by 2 plus summation of n equal to 1 to infinity n cos n omega t plus bn sin n omega t. Am I right? Last time I made a small mistake, that is, instead of n omega t, I put omega nt. The problem is that omega is not randomly varying. Then omega will also become an unknown parameter. Here omega is constant. You are just taking the harmonics of the omega. That is omega 1, means omega, 2 omega, 3 omega, 4 omega, 5 omega, like this way you are doing. Okay, makes sense? Very good. So what will be my residue? Residue will be, anybody? Simple, a0 by 2 summation of n minus n equal to 1 to infinity n cos n omega t plus bn sin n omega t minus y of t. It can be either side, it hardly matters. And that is the important point, we are doing the square. Because otherwise what happens? We are doing the minimization problem, so it can go to negative side also. So it will not actually going to solve. So we need to do with the squaring of that, so that, so r square we will take. So r square, so we will do the r square of it. And now if you see, what are my unknowns? Unknowns are a0, an, bn. An, bn is not not two terms only. These are the series terms, like a1, b1, a2, b2, a3, b3, like a4, b4, like this way. Okay, so I have to do the integration in a series manner. So if I see how many unknowns are there, if I go for the n number of terms, so like instead of infinity, if I go for n number of terms, how many unknowns are there? 2n plus 1. So unknown will be 2n plus 1, because one unknown is coming from a by 2, and here it is in two terms within n, an and bn. So it will be 2n plus 1 number of unknowns we have to calculate. Okay, so humongous job. So now first thing, so first integral will be this with a0, integral of r square d that will be dt, that will be equal to 0. Okay, now once we are doing that, how can we write? First thing we will write integral dr over r square dr over dA0 dt. We can do that. I do the differentiation as like a chain rule. Okay, now if we do, that will become 2r del r by del A0 dt. Okay, now if you see r is r, not a problem, r square. R is that r, and del r by del A0. What will be del r by del A0? Del r by del A0 will be how much? 1 by 2. Make sense? All of you agree? Perfect. So we will have integral r dt, that will be equal to 0, because that 2 and this will become 1 by 2 cancel out, and we will have only r into dt. So we'll just perform that integral and we will be done. Okay, agreed all of you? Very good. What will be the next set of integrals? Because this is the single integral happened, now we will have set of integrals. So set of integral, I will just put, instead of in, I will put it maybe j. So del aj integral r square dt 0. So what will be integral del r square del r into del r over del aj into dt, that will be equal to 0. Again we will have, this will be similar manner 2r. Now most importantly, what will be del r by del aj? Anybody? Very simple thing. That will be, is it, yeah, so that will be cos j omega t, because you will have it in can be also like, in is like omega t, 2 omega t, 3 omega t, 4 omega t, some of the things are coming, and you are doing for a particular one with j, because that is also varying. So yet one time you will get that value only. Make sense? Make sense? Everybody understood that point? Anybody, if you have any confusion, please feel free. Please feel free if you have any confusion. Anybody? Everybody got that? Perfect. Very good. Okay. So now we will have 2r, and then we have a j. So we will here put it cos j omega t dt that will be equal to 0. Make sense? Yes. Any doubt? Please. We are differentiating to get the exactly over the domain, because that t is varying throughout the domain. So that's why we are integrating it over the domain, because otherwise what will happen, for a particular point maybe you have calculated, but that not be valid for other points. You will get a very nice value for a particular point. What about the next point? So you have to take it, integrate over the full domain of your interest. Make sense? Okay, very good. Yes, please. Yeah, let me write the full thing. Once you have a question, so let me write the full thing. That's why I was asking that if you have any question, please feel free. Don't worry. Okay, now let's write the R. R will be A0 by 2 plus A1 cos omega t plus A2 B1 sin omega t plus A2 cos 2 omega t plus B2 sin 2 omega t plus A3 cos 3 omega t plus B3 sin 3 omega t, so on. Okay, now let's think we are doing for A2. Let's think we are doing for A2. Okay, so what will we do? Del R by del A2. That integration we are performing. This case we are trying to do del R by del A2. So if we do del R by del A2, what will be coming out? Cos. Now please try to match that two things. This is 2, this is 2 here. So once you are doing del R by del AJ, you will get cos j omega t. Make sense? Thank you very much for asking that. Because that is important to mention. Because otherwise, I am sure that lot of people have also that confusion, but they did not ask that. Okay, clear? And also, if you do similarly for like let's say you do it for del B3, you will get sin 3 omega t. Please check that two notation. So you are getting del R by del Bj will be equal to your sin j omega t. Clear? I think now it is crystal clear. Nobody will have any confusion after that. Good. Perfect. So we see why it is coming like that. Okay. And also we have done the next step. Exactly similar manner we will go and we will get 2r sin j omega t dt, that will be equal to 0. N is actually denoting the full summation series. If I again put n, we will get confused. You understand, na? Because n is always varying from 1 to capital L. Okay, whatever the term we are considering. Now, once we are doing the other, means we try to calculate the coefficients, we have to use another notation so that we can able to calculate it sequential manner. Otherwise, it will get confusing. If you again use the n, then what will happen? Then definitely surely you will get confused, because one is taking that full series. So you cannot actually define with the another same notation. You have to use the other notation. Okay. Perfect. So we will get that way. Nice. Now if we see this thing is done. Now the point is that now we have to start calculating this thing and try to find it out what is happening. So we are having r dt equal to 0, 2r cos j omega t full integral equal to 0, and 2r sin j omega t dt, that is equal to 0. R itself is so complicated, Now we have so many things with it. So good, no issue. Yes. So maybe just I will try to rewrite all the equations again. We will have r dt equal to 0. We will have r sine j omega t dt equal to 0 and r cos j omega t dt equal to 0. So that is j equal to 1 to capital N. So we have this is a single equation. This is n number of equations. This is n number of equations. So we have total 2n plus 1 number of equations to solving that 2n plus 1 number of unknowns. Wow, so great. So, and what is our r? And r is equal to a0 by 2 plus summation of n equal to 1 to n cos in omega t plus bn sine in omega t. Okay, that was my full term. Agreed, all of you? Minus? Yes, minus by t. Perfect. Yes, that is my r. Perfect. Exactly. Good. Scared or something? Don't worry. If it is something award series, we should be scared. But it is Fourier series, so you don't need to be scared. Yeah, I'm coming. Why we don't need to be scared? So integral a0 by 2 plus summation of n equal to 1 to n cos omega nt plus bn sine minus this should be equal to into dt will be equal to 0. Okay, good. So our target is what? We have already done that. Minimize r you have already done. Why? Because you have already get those equations which should gives you the minimization of r. So minimization of r objective is completed. A0, A1, A2, A3 you have to calculate. So don't forget what is your goal. Then you cannot able to reach there. Okay, perfect. So now if you see, you have to calculate A0, A1, A2, A3. Perfect. Makes sense? This type of thing happens once we see this type of integral. This thing is the most fast point comes that okay, we forget what we have to do. So don't get diverted. So now start writing it. Integral dt by 2 a0 plus. Just we will focus in our objective. We will have to calculate a0, a1, a2, a3 like this. Okay. So do that. Integral. Or maybe I'll just take summation n equal to 1 to n cos in omega t dt n plus integral sine in omega t dt bn equal to integral yt dt. Can I write from this equation to that? Very simple. What I did, that integral is like this. Sorry, this dt. So I just take the integral inside and try to take the coefficients out because we have to calculate the coefficients. Okay, so if you see, I can say that summation is all over. So if I try to write this as like a row vector and column vector equal to a particular value, then what can I get? Integral of dt by 2, which is nothing but t by 2. Obviously, dt by 2 is nothing but t by 2. Then we will have integral of cos omega t, integral of sin omega t, integral of cos 2 omega t, integral of sin 2 omega t, integral of cos 3 omega t, integral of sin 3 omega t, like this, so on, multiplied by a0, a1, b1, a2, b2, a3, b3, so on, equal to integral of yt dt. If you see, this is 2n plus 1 cross 1, and this is, sorry, extremely sorry, this is 1 cross 2n cross 1, and this is 2n plus 1 cross 1, so you will get 1 cross 1. It is required now subsequently to understand how the other integrations will happen, because this is not the only expression. We have other 2n number of equations. Okay, up to this is clear, no doubt, no confusion. Very good, but please practice also. Okay? These are not a matter of joke. Okay. Because if you do some step, means if you understood, you will do it very clearly, but if you did not understood it, just try to remember it, you will definitely make some blunder. So definitely practice it also, and also try to understand the philosophy, that how it is actually solving it. Okay, so this thing is clear, very clear. Okay, next step, r j omega t dt. Okay, that integration. So let me go to the next slide. So that has something interesting thing. R sin j omega t dt equal to 0, and r cos j omega t dt equal to 0. Interesting matter. So let's try to expand it. Obviously, we have to expand a0 by 2 plus summation of n equal to 1 to n an cos omega in t plus bn sin n omega t minus y of t, whole thing is multiplied with sin j omega t. We have an integration all over the thing. Quite complicated. Like last time, we do not have that sin j omega t. Now we have that. Okay. So now if we see what will happen, a0 by 2 sin j omega t dt. Okay, I will also rewrite it like this way, 1 by 2 this into a0. So my target, don't forget to calculate a0, a1. So I try to write the full thing as the coefficient of those unknowns. So that is my objective, to write that in such a manner that we are getting all those complicated terms as the coefficient. So I will put all those things in a matrix, do the invert and get solve it. So that will be my final way of solving that full thing. Okay, good. Plus we will have summation n equal to 1 to n integral an cos n omega t into sin j omega t dt into n plus integral, not n here, that n should not be here, into sin n omega t into sin j omega t dt into bn. So that thing will be inside the bracket equal to yt sin j omega t dt. Okay, now once you will do it, you will have n number of equations because you will substitute the j value from 1 to n. So first equation will be for j equal to 1, second equation will be for j equal to 2, third equation will be for j equal to 3, fourth equation j equal to 4. Like this way we will go up to capital N. Okay, 1 to capital N. Okay, anybody, any difficulty? Please feel free. Please feel free if you have anything in your mind, coming in your mind. N is automatically varying inside that, because you see n is from 1 to n automatically is there. Like we will have a0, a1, a2, a3, a4, b1, b2, b3, b4. Things are automatically coming inside. Okay, means if you see, these are the unknown coefficients. An is actually representing the set of unknown coefficients, and this j is representing the set of number of equations. You got that? So 1 means, if you see in that matrix, if you come into that matrix, if you see that a0, a1, a2, I mean a0 you forget, a1, b1, a2, b2. So these are actually corresponding to these columns, and the rows are coming by varying the j. So if I say this is the variation of n and this is the variation of j, that is why this 2 is required. If you put both the thing n and n, first of all, that is mathematically wrong, and if you somehow do it, you will make yourself confused, because this thing is itself is very confusing. So don't add up any confusion further. So then it will become much more complicated. Okay, you got that part now also. Now it is clear that what is n and what is j. Perfect. Is that clear to you also? Good. So now this way the thing is coming. Now here the most important point is in this equation, in this expression. So actually Fourier series is a orthonormal, or first of all it is an orthogonal series. So what is the meaning of an orthogonal series? Anybody has any idea of the orthogonal series? Maybe it become too much mathematics class, I'm sorry, but what to do? Structural analysis, I told in the very first class that it will be like a full mathematics, so don't worry. So what is the orthogonal series? Orthogonal series is such a series, like you have some terms, maybe phi of x, you are just expanding it, so you are writing it like, so suppose something is there, you are writing it like this way with some unknown ci. So that ci you are trying to calculate, and you have some functions like this, like here it is sine j omega t, cos j omega t, like this. So you have some function and you expand it completely. So that's a series. And if these coefficients follow this criteria, that if you do the domain integration, when I is not equal to j and some value maybe a, that is orthogonal series only. And if this thing also happens, it turns to be the orthonormal. So this thing can be rewritten in a more mathematical precise form as do you know what is the symbol of that? Dirac delta, exactly. You maybe have studied that in the solid mechanics course. Okay, so what is the Dirac delta? Anybody? Exactly, I equal to j, it will be a constant value, or it is 1. Once if you substitute Dirac delta directly, it should be 1. It cannot be any number. 1, and if I is not equal to j, it will be 0. You see, that exactly match with this. And the beauty of the Fourier series is that all the coefficients of the Fourier series is following the orthonormality. Therefore, what happens? Once you are doing this integral, for example, integral of cos in omega t into sine in omega t dt, you will get 0. Okay, here there is a small thing, that is the time domain, how long you are integrating. That should be also integer power of omega. So if we think that t, which is equal to 2 pi by omega, and if we do the 0 to t, we should always get to 0. Okay, not okay, no issue, we can do that. We can check whether are we getting it 0 or not. Simple, it's a sine cos, not a problem. Okay, okay, that is j, right? Yes, and when it is n is not equal to j, we will get it 0, and if n is equal to j, we will get, it will be 1 or maybe some value, 1 or some value, or maybe means some constant. Maybe I'll just put it something, maybe x. So x is not equal to 0, some non-zero constant will come. It will depend actually, like how many cycles you are integrating, then whether, means these are maybe not orthonormal. Means once it is orthonormal, that will be, that need to be 1 actually. Means so that is the orthonormal case. So orthonormal, it will become 1. So those things also scaled up and down. Okay. So yeah, so this thing happens. So now let's, so do you want me to prove that cos n omega t into sine j omega t all are equal to 0? And that is not only for cos and sine, that is even if you do it sine n omega t into sine j omega t dt, that will be also Dirac nj. And if you do it cos of n omega t into cos of j omega t dt 0 to t, that will be also Dirac nj. All three combinations are giving Dirac nj. This one is always 0, first one is always 0. Yeah, so cos and sine is always 0, it will never gives any value. Okay, and other two case will gives you Dirac, because once they are equal, that will be 1, other case it will be 0. Now please tell, do you want me to prove that, or you are okay with it? Means you can also just type in the computer and check that, you will get. And also if you open the book of the Medovich, in appendix this full thing is driven and derived, so there also you will get that. Okay, so you can also refer there, all the integrations they have solved, because if I try to solve it, I have to solve that 6 integrations. Oh. That's like little bit thing. So you can refer that book, and it is very clearly done that in appendix A, I think A or B, in the book of Medovich, I think theory of vibrations. So if you refer that, it will get that. Okay, so any doubt up to that? Okay, but the good thing is, why we did so many things, but we have to also remember we are not doing the mathematics course, we are doing structural dynamics. So now tell what we got and what is the utility of these, all those things. Did we get anything fruitful or not? Yes, we got a fruitful things. That is first term. Okay, we have to do integration, can't avoid, and that is also not difficult. If you see, we have half, forget, half is a constant number, you can take it out. Sine j omega t dt. We all know what is the integral of it. What is the integral? Cos j omega t by j omega half a0. To solve the integration, you can put the limit from here to here, plus. Now this monster we can able to solve. That's the biggest thing. That's the biggest relief we will have. Because now here, what is the thing? Cos n omega t into sine j omega t dt. We know that value should be always 0. So whatever you do, it will become 0. 0. 0 multiply n. Okay, no issue. Means we will have like this way it will happen. Got that idea? Because n are not a constant, it is varying na, a1, a2, a3, a4 like this way. So all are having the 0 coefficient. Make sense? Because you are multiplying with some j and that all are getting 0. Because none of the case it will have some any value. Cos and sine will not give any value in any of the case. It will become full 0. Okay? Next case. Plus. It's a mistake. Sorry. Thank you for pointing it out. Because it cannot be happen. Cos and sine cannot be give some value. Sine and sine can give some value. Cos and cos can give some value. Actually, I want to mean that thing actually. Cos and cos can give some value, and cos and sine can sine and sine can give some value, but sine and cos cannot give any value. It is always 0 if you do the integration. Also, think it very simple manner. Once we are telling the orthogonal, we also know that cos and sine are 90-degree phase difference. If we think it from that aspect, also they are orthogonal. Okay. So their product are always getting 0. Clear? Now the next one. So this one, simple, we got that. What about this one? So at j, we will have certain value like xj, bj, and all others are 0. Only one case we will have xj. I am not writing 1 because I don't know whether they are orthonormal or not. You need to check that whether it is coming exactly 1 or not. If it is coming 1, you can put 1, much easier. But if it is coming some value also, it's okay. You can have that particular value there. Okay. And then all other will be 0. Means suppose this is, let's say, 1 plus 2, whatever. When which is not equal to j. 1, 2, 3, 4, 5, whatever is coming, and which is not equal to j, that will be 0, and which is equal to j, that will be something xj. Makes sense, na? What happened? All of you are clear or not? Any doubt in anyone's mind? Any doubt? Good. Equal to y of t sine j omega t dt. Can we do anything here in the last term? No, we cannot do. Because that is y of t is a unknown thing and it's a series of points actually. So here basically we have to perform some sort of numerical integrations. Because that's some points we cannot do. Okay. So now try to put it here. In that matrix. Okay, so that's why some people actually do not write it in this form. A1, B1, A2, B2. No, people don't prefer to write it in this way. Rather, people prefer to write it in this form. a0, then a1, a2, a3, an, b1, b2, b3, bn. Okay, what's the benefit? So first thing you are same. Next one, you will put cos of omega t dt, cos of 2 omega t dt, like this up to cos of in omega t dt, then sin omega t, sin 2 omega t, like this way, sin in omega t. Okay, we will do up to that. Now here what will happen, what will you do? Look, first term is this, or maybe I can just write this way, so that I did for the sine term. Okay, so maybe first you are doing for cos. Okay, or if you do it for sine also, not a problem at all. So if you do it for sine also, okay, no issues. Sine we did. So this portion you just take it out. So what happened? You will have, that is 1, this is in, this is in. Here also this is 1, this will be in, this will be in. Okay, now what happened? First in number of equation you are doing maybe for sine. Okay, so what happened? This front portion whatever you are putting, so that is maybe 1 by 2 sine omega t dt. You placed it, that first term integration, sorry, that term. Okay, whatever is coming will go there. Okay, we will change the color. Then this full thing will be 0, because cos into sine will give full 0. And then there will be only x1, so there will be a diagonal term. Make sense? After that what will happen? Again you will have somewhere here half of cos omega t dt, like this way it will go, cos omega t, cos 2 omega t, cos 3 omega t, cos 4 omega t, whatever you are multiplying there, that first term, whatever will started coming here, that first term will be there. Now you will do it for the cos. So first cos term will be coming, and then second this one will be again maybe y11, y12, y22, y33, like this way the terms will coming, and this will be big 0. Ha, that is something now solvable, because now you mostly, or if you do it other way, then you will have a complete diagonal matrix from here. Because if you do first the cos and then sine, you will have a complete diagonal matrix in this portion, and then one row and one column is populated, and other is like a full diagonal matrix with this thing here, and here you will have a populated matrix. I mean, so these are vectors, so that vector will be there. Now think, once we have a diagonal matrix, almost a diagonal matrix, means that is just like a only one row and one column is populated, and rest twin number of things are fully diagonal. That's a big relief actually, when we can easily able to solve it now, because that inverse and all those things will be quite easier, because it's a almost diagonal matrix. By the way, did you get that essence of how to get the Fourier transformation thing? So whatever the signal you will have, you will just do that repeatedly, doing these integrations, performing these integrations, and you will get the coefficients out of it, and you will able to do that. Any doubt, anything, please? Right side is this way, that first, like if we are doing with the sine, so sine dt, then sine 2 omega t dt, like this way. Bearing G. These are the different coefficients of like a sine, cos are started coming there. So these will give us the value of A0, B0, like this thing. Now there is another point, interesting point. If you do not have their orthogonality, suppose you just assume some function by yourself, you don't bother that okay whether they are orthogonal or orthonormal, you don't care, you just made a series by yourself and maybe you named it, it's my series, you just take it and you start doing it. Can you really able to do it or not? Or what type of problem will you face? Or suppose if you face the problem, can you able to resolve it? Because now I hope you get a generalized idea that how we can able to do it. Now there was a cos and sine thing, okay fine, and they maintain the properties, very nice, very good, we can easily get that. But suppose if you are making it by yourself, some function, you means we are not a mathematics student, we don't know maybe that okay what series should be taken, all those things. Suppose if you choose some series and if you try to do it, what type of problem will be happened? Anybody, can you guess? Okay, maybe let me give you a hint. So first thing is that if they are not orthogonal, this matrix, like what is the submatrix, whatever we got, n cross n submatrix, 2n cross 2n submatrix, that will be not a diagonal matrix. That will be a full populated matrix. Okay. Now, and most of the cases that integrations you have to perform. So now here, how many integrations computer has to perform? Tell me. Here we will have, so in that right side we will have 2n plus 1 number of integration. Here we will have 2n, here we will have 2n, 4n and 1. So 4n plus 1 and 2n plus 1. So that will be total 6n plus 2. Total 6n plus 2 number of equations, integrations computer has to perform. Okay? So now 6n plus 1 number, 6n plus 2 number of integrations computer has to perform. And if you do not bother about orthogonality, and if you use your function, you have to perform 2n plus 1 square plus 2n plus 1 number of integrations you have to perform. Now maybe just put some number, maybe put n equal to 10 and check how many coming. So the first number is become n equal to 10. If I put first equation is 62, and next one please calculate. Come on Ray, come on please. Huh? 462. So automatically you can understand that computational time will definitely increase, because computer will also take its time to do it, na? It is not like means if you are not writing the code efficiently, or if you are not making your computational method efficient, it will take more time, definitely. So like this type of, and also you have to understand again, there will be another problem, that is the inverse of that matrix. Once it is like in the 2n cross 1 equation, if 2n cross 2n is like a diagonal matrix, its inverse will be much easier. Whereas if you are trying to invert a full 2n cross 2n plus 1 cross 2n plus 1 matrix, that also itself will also take more time. So here time consumption is how much? From 62 to 462. So just like if you calculate quickly, it will be 7 times. So you see clearly 7 times, and integration and the like the matrix inverse will also take much more time. So more or less like you will make a difference of 10 times performance reduction can be expected. So your computational speed will reduce drastically in those cases. So why I tell those things, because to give you an idea how the computational speed and all those things are correlated. Like sometime maybe once you will do the research and all those things, you will face the problem that you're running some code, saying, man, code is running. It is not good that to tell that my code, my code is running for 10 days. No, man, it is not a good thing. You should go and check that maybe you have written the code very inefficiently. So that you should go and cross check. It is not a matter to take credit. Rather, you should feel yourself that there must be some problem happened somewhere. Okay, that maybe you have not written it in the way it should be written. So obviously, like a 10 times performance difference, you can understand. Like suppose if your code has to run for 1 day, it will take 10 days. Simple. And you just left your color and say, wow, my code is taking 10 days. So don't do that. Okay. Good. Nice. So that is more or less we got the idea how we can able to get that. In the MATLAB, if you see that is so efficient, you will just give the command FFT, you will get the result. So these are so efficiently written in the MATLAB. Okay, so that we see like how we can able to solve this thing. Now there is another one is the transformation, Fourier transformation. So there, what we are doing, we actually go from directly time domain to frequency. So here also we did it time domain to, we just map it to that frequency coordinates like a sine cos, and we go there. That also can be done in another separate way. That is, suppose we have y of t, we can write it y of omega e to the power of minus I omega t d omega. So that is IFFT, and you have FFT. So that is your FFT, Fourier transformation. So you can actually, if you have a signal, let's say in the first case you have a, so just assume this is the first case and this is the second case. So in the first case, you have the signal in the time domain form. Okay, and from there you try to go to the frequency domain. So that means you have a yt, so that's some signal you are having, and you already seen that we can able to rewrite it so many things like a frequency versus amplitude. So you try to see that how these things are varying, so you will get an amplitude plot like this. So here the x-axis is frequency, here the x-axis is time. So that conversion we can do by this function. That is the Fourier transformation. So we have all the nodes. If we just put it, we can get that type of graph. And once we are plugging this, we can also try to get. And so this process is known as FFT, first Fourier transform, and this is known as IFFT, inverse Fourier transform. So these are telling what are the frequency contents associated with a signal, like we have a signal, what are the frequency contents associated with it? Why it is important? Because suppose you are making a structure and you know the natural frequency of the structure. Okay, that you know root over of k by m, and we will also study the MDF system, and there we will also see that how the different modes and all those things will come. So in those cases, once we are exciting with some excitation, if the natural frequencies of the structures are matching with the excitation frequencies, then the structure may show the resonance. We have seen that single degree freedom system plot. If they are matching, it suits. So once we are doing that FFT and IFFT thing, we can able to find out where are the peaks, where the things are jumping. That we can able to identify. Maybe then we will complete that thing in the next class, and we will, after that we will shift to multi-degree freedom system.